Hey folks, and welcome to the channel. Today we're looking at the build of a cross slide for a client who is refurbishing an old lathe. In the previous section you saw me cutting a slot down the middle of this block of steel, which I did square up. There was a little picture of that earlier. I may have a different video on squaring up blocks, but those are pretty common on YouTube. What I'd like to do is put a slot down the middle to provide a little bit of relief for when I use a larger tool on it. And that relief, although it does create an interrupted cut and is hard on the bit, it seems to me it creates a smoother finish because there's some place for the chips to be discarded as it's cutting through. So you can see this 2-inch cutter that I have on the mill right now, just working through down the part, and it's going to take a couple passes to get through here. Basically it's just cutting to a depth specified by the customer's machine, to eventually put a dovetail slot, and that dovetail slot slides across the top of his lathe. So anyway, here you go. So here what we got going on is starting to cut the dovetail slot. You can see the dovetail cutter in there, and just chipping away at the edges little by little to the desired width according to the specifications provided. Also note that when I cut the slot depth with the 2-inch end mill, I left it a little bit shallow. Reason being is because this dovetail cutter obviously cuts on the face as well, so it's going to take off a few thousandths as I'm going across, and then I can take a little bit more off later to get it to the exact depth. Now this dovetail slot also has to be provisioned with a gib. I think the part is called a gib, and that's a hardened piece of steel that runs down the length of the part with screws in the side to tighten it against the top slide, which this part scrolls back and forth along. Now later in the video you'll see me positioning the holes. There's specific height, diameter, thread pitch and whatnot to for the screws that or the bolts that go in the side to tighten the top slide against the cross slide. Here I'm changing out a dovetail cutter for a fly cutter, and the reason for that is in the position at the bottom of the dovetail right there. I want to create a little bit of a relief. So the bit that's in the dovetail cutter is ground to an angle that's sharper than the 60 degrees on the dovetail. So I'll be able to get in that little slot and cut a bit of relief at the tip of it. That's just so that there's no binding at that point as the unit is sliding across. The fly cutter will also take a little bit off the surface to get it to get the slot to the proper depth. And as you may very well know, the fly cutters always, when well sharpened, they provide quite a nice surface finish.
Let's see if Milo can get back up. Go get him. Go get him, Moose. Go get him. Go get him. Go on. Just gonna give it a try. Here he comes. Look out, Moose. Come here, Moose. Come here. Moose. Come here. Good boy, Milo. Wow, that's impressive. We're just gonna hang out here for a bit. Gotta fix your vest.
Alrighty, so what's going on here, I put a test part in the vise, and the objective is to cut a T-slot in this test part to fit the dimensions required. I'm starting off with looks like a 3/8 inch carbide end mill. Cut the slot to depth and then cut it to width. And later we'll see a T-slot cutter come in. Now I don't have a T-slot that, we rarely do have a T-slot that exactly fits the right size of the T, so it's multiple passes, but we will have a look at that shortly. You can see here too, I'm using a mist coolant to keep the tool and the part lubricated and relatively cool, and I'm also supplementing that with a spray bottle of coolant when I see that it's required. And in goes the T-slot cutter. You can kind of see from the close-up that that T-slot cutter is maybe 4 millimeters at the most, so it's going to require a couple passes through there to get that slot to fit the T-nuts that were supplied with the part that you can kind of see in the background there. The T-slot cutter is also referred to as a woodruff cutter for cutting circular keys in keyways and whatnot. There you can see I'm replenishing the fluids. That Gatorade bottle there is full of coolant water mixture for the mist cooler, and the reason I don't take that from the main reservoir is the main reservoir is down really low on the machine, and I was having some issues with it being able to pull up fluid from way at the bottom of the machine, because the mist cooler uses only air pressure, creates a vacuum to pull up the coolant and mixes it with air to spray on the part. I am manually feeding that woodruff cutter through the slot. It's cutting on both sides, I could use the power feed, but until I'm confident that the Woodruff cutters are going to be able to handle the load and get a feel for what kind of feed rate it could handle, I'm just doing it manually. So now that I have a sense of what the cutter and machine can handle, I'm using the power feed. Alright, so that cut went all the way through. Just readjusting the height to make another pass in the T-slot to increase the depth of that slot. A few more light passes here to clean that up and get it to closer to the required size. About to test fit the part here. Yeah, it's not quite fitting. Nice and snug. Rather have it too snug than too loose. So a little file, maybe take the burrs off those edges. Still pretty snug in there. Alrighty, so as I mentioned earlier, next is to drill the holes in the side of the part, drill and tap the holes in the side of the part for the gib adjustment screws or bolts. And here I'm just, I forgot what I was doing. Yeah, whatever I'm doing there. Yeah, repositioning the part for the gib adjustment holes and taps. Just finding the edge of the part there and storing that in the DRO. Center drilling those holes. As I mentioned in the scroll, the original part had holes in it already. So I'm just copying the location of those holes. Now the other side of the part, in this case, is angled at 60 degrees, so you can see the bit is struggling a little bit to get through the angle on the other side. I don't have a close-up shot of that, but I wish I did. This bit here is the proper bit size for the, I think it's a 1/4 20 that needs to be tapped in. So just going through each hole again with the proper bit size to prepare for tapping these. here I'm just changing out to a center drill to clean up the holes, and also that helps in making an entry point for the top. Yeah, I'm looking a little bit curiously at this, wondering, is this gonna work? We will see. I mean, that is tool steel, and the hole is about 1 inch deep. So chances are the bit might break or the machine might lock up. So I gotta kind of get this right. Just triple checking everything there, and gonna run it at about 120 RPM. So this part, all these holes need to be threaded. And to do this manually, it's probably like 3 hours of work. You know, you stick the thing in and you turn it. But I just tried this.
Put the thing in there and it's good for you.
I thought, there's no freaking way. There's no freaking way it's going to cut through all that steel.
Hey, come on, let's go. What kind of bit is this?
It's a good quality
steel or carbide?
1/4 20. I think it's just
really nice
high speed steel. Yeah. Freaking butter. First one I did was like, no freaking way.
And you have the right screws for that and everything?
Yeah, that's why it's the standard 1/4 20 threads per inch.
That's really nice. I might get you to do that for a month.
I gotta go in this clean up those edges. 3D.
Yeah, well, yeah. It's good.
I just had to share that because I just couldn't freaking believe it.
It's like butter. It goes through it so easily.
I know.
It's not even heated up or anything.
That's not. That's steel. That's aluminum. That's not aluminum. So these oiler ports, about centered on the part, smaller hole goes all the way through to the dovetail, and the outer part I'm just drilling here to fit the brass oiler port insert. It's a press fit to get in there. And I know I'm not supposed to be wearing gloves, and I did fairly certain I took them off shortly afterwards. I know I was doing something else, I needed gloves on and I forgot. Not a good idea. putting a bit of a chamfer on those holes just to clean up the edge a little bit. Here, just fitting the little oiler port in there. You see it goes down a little ways and needs to be tapped in. So it has to be a fairly accurately cut hole. Fortunately, they're a standard size, and I was able to use a standard size, likely a metric drill bit for that. These you do have to be a little bit careful with, because if you put too much pressure on the inner part of the oiler port, it presses in, and then the ball doesn't seat properly as you're oiling it. And just using a part that has a hole in the middle of it there to go around the ball to kind of hammer that port in there. There we go, nice and flush. So again, the part that the customer left me, that this is supplementing and or replacing, had holes to mount the lead screw, and this has to be really quite precise, especially side to side, as these if it's not, then the lead screw would be bent as it's being drawn in and out, and cause unnecessary wear as well as unnecessary resistance. There's the edge right there. Just mark that in the DRO x-axis. And marking the y-axis at the top of the the dovetail on both sides. So here I'm using a half inch, I think it's a half-inch end mill to drill these holes. Reason being is they need to be really straight. End mill on the top part again, a little larger end mill, the size of the nut of the bolt that goes through them. This side of the hole is larger because it has to capture the head of the bolt as it goes into that hole, which I think I'll show you in a few minutes. Right, on this side here, you can see there's a nut on that bolt. There's actually two nuts tightened against each other, and the reason for that is in case you can't chuck the bolt. I wasn't able to chuck the bolt on the head of that nut because it would just wobble around. So you put two bolts on the nut and chuck it up that way. There you can see the bolts in the top machined down so that they're flush with the surface or just slightly below the surface, and to size so that they grab the mechanism that's in the dovetail at the bottom. So there you go.